Our first speaker is Jerry Smith, professor at San Jose State. He has sampled our county streams since the 70s and 80s and has taught fishery management, aquatic ecology, and conservation biology at San Jose State University. And I will be, I'm sharing my screen to show his slides. He's on the phone, just in case you're wondering why the slides are on from my screen. Okay, take it away, Jerry.
Okay, in addition to the long time sampling that I've been doing in Santa Clara County streams, annually since 2007, I've sampled Penitencia Creek. Since 2013, I've sampled Stevens Creek, and since 2014, I've sampled Coyote Creek. And so I will be talking about how the ecology works in those streams and what the status of those fish in those streams are. This steelhead shown here is actually a fish from 2011 in Penitencia Creek, and based on its scales, it spent 1 year in the stream, actually grew pretty good because that was downstream of the park in augmented water used for percolation in the channel that occurred back in prior to 2013. Spent 1 year in the ocean, came in and got stuck in the stream, no longer silvery. It looks like a rainbow trout. We have both rainbow trout and the Anadromous migratory steelhead in these local streams. Next slide, please. This is a map that was made of the fish communities in Santa Clara County, cooperative between myself and the Water District a number of years ago. And in this map, the red are the areas that were steelhead at that time. Blue are the rainbow trout, resident fish present above the dams or otherwise blocked off from things. And green are the downstream areas that are either lower stream flow or warmer water that are potentially steelhead that may vary from year to year. We also have Chinook salmon in the system, and those are mostly downstream in Coyote Creek and Guadalupe River watersheds. And since they don't spend the summer in the stream, the juveniles move out as only 3 to 5 month old individuals. They're kind of independent of summer stream flow conditions, so they water temperatures in summer, stream flow in summer is not a factor in their biology. If you notice in the upper right, Upper Penitencia Creek was listed as steelhead at the time we made the map, but since that time, the steelhead have disappeared, and I'll talk more about that. And it's basically a rainbow trout population in Penitencia Creek and Alum Rock Park. What this map also shows is that the reservoirs in the county were basically built and still operated for storing winter water, running it down the stream to percolate it into our groundwater system. The yellow section here is the percolation zone that actually goes into our groundwater system, our deep aquifer. The pink further downstream, further north, is basically over a clay layer, and percolation into our deep aquifer doesn't occur there, but it may percolate into perched aquifers and reemerge downstream in some of these lower reaches of the stream. Next slide, please. A little bit about the biology of these fish to try and understand what we should be concerned about in terms of their ecology. Steelhead basically migrate into the stream in January through April. Sometimes they can come in December, but basically storms in December are not going to attract very many adult steelhead. The fish will spawn in January and April, and then they will rear 1 to 2 years in the stream, depending on how good the rearing conditions are. If you actually have fairly high summer stream flow and good feeding conditions, the fish may reach the 6 inches minimum that they need to go to the ocean in 1 year. If the stream is just a trickling little stream and food is fairly scarce, it may take 2 years. Now, the feeding times, the best feeding times are actually in spring. So when it comes time for the smolt out migration, what actually happens is it's a very extended period of time from mid-March through May. And that seems like a pretty weird time to try and out-migrate because the stream flows are rapidly dropping. But that is also a feeding time. And so the fish, depending on how big they are feeding at that time to increase their size so that they can survive in the ocean. A large fish might be able to go early in that period of time. A smaller fish waits longer. So the migration for smolts is an extended period of time. It's not something that if you give a 3-day pulse, they all go at once. This is a major constraint on steelhead in North County. The adults can go, they know where they're going, they're already big, they just want to reproduce and get upstream, and so they will go in a matter of few days. So a pulse, whether that's urban runoff or total stream flow increases with major storms or releases from reservoir, will allow the fish to move up very, very quickly. Now, we also have Chinook salmon in this system, and they basically started showing up in the 80s. And what was going on there is a number of things. One was in Guadalupe River, they were processing contaminated groundwater from IBM area, shooting it in the air, stripping the toxins out of it, and then putting it into the Guadalupe River. So there was actually stream flow that would attract a fish. Now the Chinook salmon migrate in fairly early, August through November. But what was happening is Central Valley hatchery fish were not getting through the delta, and so they were trucked around and put in the upper bay, and when they came back, they went for whatever was available. And so if there was stream flow, Chinook were attracted. So the Chinook system is basically subsidized by Central Valley strays. Now, they spawn in a little bit, successfully spawn anyway, later than their migration period, because in August, the water temperatures are too warm for egg survival. So in October and November, when the streams cool down, then they can successfully spawn. And there is successful spawning and rearing in Coyote Creek and in the Guadalupe River system. Now, those fish that hatch out in December and later they only spend 3 to 5 months in the stream and then go out. So they're not here in summertime. They can use parts of these watersheds that go dry or warm or have water quality problems in summer. But they also then out-migrate essentially at the same time as the juvenile steelhead do. Because this run is largely driven by the Central Valley fish, the availability and number of fish from year to year changes. And then the additional factor that really makes a difference in the number of Chinook in our streams is Chinook have been very sensitive to changes in ocean conditions. So, for example, in 2005 to 2006, the ocean basically collapsed as far as feeding Chinook salmon. They use different portions of the ocean than the steelhead do, more similar to coho salmon. But so after that, there were very few Chinook coming back to the Central Valley and very few of the strays coming back to Santa Clara County. Next slide, please. Now, the rearing in the stream is a fairly complicated situation. So if we look at the F and G in the center there, that's feeding and growth. It's affected by a large number of features. One of the things for steelhead and for Chinook, they're oriented to feeding in fast water, feeding on drifting insects, kind of on a conveyor belt. And so fast water feeding habitat is very crucial for them. Slow water, they can sit and starve. Fast water, they can feed. Water temperature is a very important factor. But within the temperature ranges that we're dealing with in these streams, water temperature is largely a food-related factor. As the temperature goes up, the fish use up their energy faster and are hungrier. However, if food is really available, higher water temperature also improves their digestive rate and they can grow better. So there's really an interaction between water temperature and feeding habitat and how the fish do. Turbidity and sunlight affect light and the vision. So a stream that's very muddy or muddy in wintertime and springtime reduces the ability of the fish to see and feed. So that's an important factor. If there's less light, whether that's shade or turbidity, you have less algae, and that's kind of the base of the food chain for many of the insects that then drift in the system to feed these fish. So the fast water habitat is what's important. So there is a trade-off in terms of if you've got limited water or limited cold water in some of these small reservoirs, if you try and keep it cold, you don't release much water, but the cold water lasts longer in summer. But then they can't feed very well. So depending on the productivity of the system, there's an optimum balance between dealing with water temperature and fast water feeding habitat in the releases from these reservoirs. Next slide, please. Okay, this is a complicated schematic of the plumbing and the ecology of Coyote Creek. And what you basically have is many parts that are affecting steelhead passage for adults coming in and smolts heading for the ocean, and stream flow and water temperature that affect the growth. Coyote Creek is a highly regulated system that supplies a major portion of our water supply from groundwater percolation of both reservoir storage from Anderson Reservoir and imported delta water, which can be dumped into the stream just downstream of Anderson. Next slide, please. Okay, this is the upper half of that schematic. You've got Anderson Reservoir is the key to what's going on, along with the imported water. Now, both the imported water and Anderson Reservoir water can be sent to the treatment plants or to the stream for stream bed percolation. Early on, up until the present time, water from Anderson Reservoir could go to either of two places, but it has to go through the same single port. Although there are multiple levels that they can release from the reservoir, they can only use one at a time right now. These reservoirs heat up in the summer, so the surface gets warm, the bottom remains cool. You would like to release cool water for the fish, but at the treatment plants, they don't want bottom water, the cool water. And so up till now, the releases in summer have warmed over the summer because of the mid-level release of water going to the treatment plant. Similarly, water coming from the San Luis Reservoir system is warm by late summer, and you don't have the cool water that you could blend to reduce that. The new Anderson Reservoir design allows releases from the bottom simultaneously with releases from further up in the water column, so you can release warm water to the treatment plant, relatively warm water to the treatment plant, at least not bottom water, and cool water to the stream, and that could blend with the warm delta water coming from San Luis, and you could keep the stream cool. Further downstream, the major issue in Coyote Creek is you have a series of 4 what used to be off-channel gravel quarries, but in the 90s, the stream changed course, and those are on channel now. Similar to the reservoir, the surface of these ponds is warm, and the bottom is cool, potentially. Cool water from upstream goes in, cool water is heavier, goes to the bottom, warm water replaces it going out. So these percolation ponds, like in the upper left-hand corner, result in very warm water going out, and it is too warm downstream of the Azure Ponds for rearing steelhead in the summertime. In addition, in the lower left, these ponds are full of largemouth and spotted bass. These are the velociraptors of the watershed, and they eat the steelhead juveniles as they're moving out. This is all in a percolation zone, but because of the drought, in February 2014 through May 2016, there was insufficient water to get past the percolation ponds in summertime, and it never made it down through. So for the whole period of time from February 2014 through May 2016, you could not get adults in to the rearing habitat and spawning habitat, and you couldn't get smolts out. That basically eliminated 5 years of rearing success in the system. The juveniles would migrate downstream, get dried up in the drying channel or eaten by the bass, and you eliminated production for essentially 5 years. Next slide, please. Further downstream, there's a Coyote percolation pond, which is shown in the upper right. This is kind of the last hub to percolate a good portion of the remaining water released from imported water or from Anderson Reservoir. On the right are the radial gates in that diagram or in that picture. The ladder is the curlicue thing next to it that goes up, but that ladder only works when the pond is full. And then there are steel panels that form the dam and can be taken out with quite a bit of difficulty in case of emergency like 2017 and the floods. With those floods, the paradox was they took out the panels so that they weren't damaged. The pond dropped in level, and so in the middle of big floods, there was no upstream access through the fish ladder because the pond was not full. So altering Metcalf to provide for the fish ladder to work under variable conditions of pond fullness would be required. And you could replace the steel panels with an inflatable dam that's easy to put in, easy to put or to inflate and put and lower down. The pond is also warm and full of largemouth bass, and if you drop the inflatable dam for a short period of time, you can flush out the largemouth bass, and so predation could be reduced. The other major problem that has occurred in the past is downstream at Singleton Road. There's a ford and a trail crossing shown in the lower right that's culverts and an inclined apron and road. Those culverts and the apron only allow fish passage under a specific set of conditions. If the flow is too low, they can't go through the culverts, and the culverts are easy to clog also. If the flow is very high, there's high velocity in the culverts, and the fish can't go. At very high flows, you can actually go over the road, but at moderately high flows, it's too shallow to go up and over the road. Metcalf or Singleton Road crossing is owned by the city of San Jose. It's part of their trail system, and that will be replaced hopefully this summer with a spanning bridge, a rail car bridge, and that will eliminate the problems of adult passage in the system. But the combination of difficulty of getting smolts out and getting adults in eliminated the 2013 through 2017 year classes, and 2018 to 2020, there are very few juvenile steelhead in the system. It was definitely at risk of losing the steelhead run. Next slide, please. Okay, this is Penitencia Creek, and Penitencia Creek is the downstream tributary to Coyote Creek. It is the one downstream tributary that could actually support steelhead. Next slide, please. The upstream portion is in Alum Rock Park, and the stream flows there are supported by a small reservoir, Cherry Flat Reservoir, that will send water down. in wet years. In a dry year like 2014, 2015, 2020, and this year, there won't be enough water to support rearing in the upstream areas, but there will be water from the mineral springs downstream to the lower part of Alum Rock Park. So this fluctuates back and forth, and this has supported resident rainbow trout and steelhead. Next slide, please. The problem downstream is that up through May of 2013, they basically were operating the percolation ponds along the channel upstream of Piedmont Road and also discharging water to Penitencia Creek. Now that water then maintained a perennial stream basically down almost to Coyote Creek in summer and all the way down to Coyote Creek in winter. However, absent that discharge, the stream goes completely dry in summer just downstream of Alum Rock Park. And since May 2013, there hasn't been spring stream flow that would allow smolts to get out, and it's been very difficult for adults to get in during dry years. So since 2013, the population of fish in Alum Rock Park is resident rainbow trout only. The steelhead have been eliminated from the system because the adults can't regularly get in and the smolts can't get out. That's something to think about since last year, fish were rescued, quote, from Coyote Creek and put in Penitencia Creek. These were steelhead. 77 steelhead were captured in Coyote Creek. 75 of them were moved to Alum Rock Park. Those fish, when they try and migrate out, will die trying in a drying channel. So we've eliminated the steelhead run in the one tributary downstream. Next slide, please. Stevens Creek has some of the same problems. We've got a long stretch of percolating channel in the middle of the watershed, and you've got a small reservoir in the system. Next slide, please. In the upstream area, you've got small reservoir, Stevens Creek Reservoir, and depending on how wet the year is, in a dry year, the stream flow that you can release from the reservoir can barely make it down to Homestead Road or even further upstream. In a wet year, the stream flow can make it down past Fremont Avenue. So that's one of the things. But it's not going to be a really high stream flow in summertime for feeding. The other major problem for Stevens Creek Reservoir is the releases from the reservoir are very turbid or muddy. If you look in the upper left, in recent years, they've been using an aeration system, pumping oxygen to the bottom of the reservoir to reduce the contamination of mercury in the system. The mercury without oxygen converts to methyl mercury, which is highly toxic. And so they're aerating the bottom, but in this process, they're stirring up the bottom sediments. And so the releases from the reservoir are very muddy. So if you look in the lower left, this is further downstream at Blackberry Farm. It's very muddy, and that means that the fish can't see very well to feed. And it also means that that fine sediment settles on the bottom. And so the bottom of the stream is smothered with fine sediment. That reduces the insects available. So the turbidity and low stream flows are resulting in relatively low numbers of fish in the rearing habitat. Next slide, please. Further downstream in Stevens Creek, you've actually got a long stretch of stream that percolates. Now, that doesn't necessarily percolate into our groundwater deep water supply system, but it does percolate into the perched water table and reemerges downstream of Middlefield Road, but it leaves a big gap. That means that smolts trying to get out are blocked from getting out in springtime because the middle part of the stream is dry. The middle part of the stream this year has been dry basically for a month already, and the smolt migration is really in its potential peak right now. The other problem was that there was a problem near Evelyn where there was a fish ladder, and there was a bypass channel upstream of the fish ladder that was supposed to take the high flows, but the channel changed and the high flows were going not through the fish ladder, but were going through the bypass channel, which is broad, shallow, and difficult to pass, especially in a dry year. Smolts were not getting out, adults were not getting in, and actually in 2013, most of the adult steelhead spawned downstream of the bypass and the fish ladder, and there was actually rearing downstream in 2013. But without completing the life cycle, getting the smolts out and adults in, there were only resident trout, older fish, present in the rearing habitat upstream in 2014 to 2016. And since that time, the numbers have been relatively low. You've got restricted or blocked adult access in dry years, and especially in the past, restricted or blocked smolt passage in a majority of years. Now, the problem at Evelyn Ladder and Bypass, that was remedied in November 2015, but the run is still fairly small compared to what it was in earlier years. Guadalupe Watershed, I don't have diagrams of this, but it has the same general problems that most of these other streams does. Arroyo Calero, Alamedas Creek, and Guadalupe Creek provide rearing habitat below their dams, but those are small reservoirs with relatively low stream flow, and there's major smolt problems in dry years getting out. Right now, since April 1st, the Guadalupe River has been dry upstream of Almaden. So there is a Almaden Expressway. There is a choke point that means that smolts don't get out. They were suffering similar situations during our past drought, and adults have had trouble getting in, although they can depend on the flashy urban runoff. There's also an on-channel pond, Almaden Lake, that has the problems of warm temperatures downstream in summer and has the problems of predatory largemouth bass in it. Next slide, please. Okay, so as a general assessment, the steelhead are scarce and at risk of loss or becoming resident trout populations, such as happened in Penitencia Creek. Water scarcity and management during droughts is a big problem. The imported water is cut off or reduced and is not allowed to be used for the extent of percolation that might be desired, that blocks the passage for fish getting up and fish getting down. We've got some infrastructure and adult passage problems at Singleton Crossing and Metcalf Dam in the latter. Singleton Crossing will be solved this year, hopefully. But in general, the biggest problem is we've got very poor smolt passage of juveniles going to the ocean due to these percolating stream reaches and inadequate extended spring passage flows. Again, a couple of days of passage in spring isn't enough to get very many smolts out. You need an extended period of time, and that's water that goes out to the bay, and especially in times of drought, it's a super bad problem, and that's when we need the water for people. And then in the rearing stream habitats, we have to worry about temperature and stream flow and balancing those, and we've got problems with sediments, turbidity, and on-channel ponds. And that's my presentation.
Thank you, Jerry. Wow, that's a pretty grim picture of our situation. It's as if humans and ecology can't quite exist. Our next speaker hopefully will have some more hopeful news. Next up, I just want to remind everybody this meeting is being recorded, so you can listen to it later or share it with others. And we are going to have all our questions at the end after all our speakers. We will entertain questions both by raised hands and in the chat. Our next speaker is Patrick Samuel. He is the Bay Area Regional Director for California Trout and has been engaged on fishery issues around the Bay for the past 5 years. And he's going to give us a little background on FAHCE. Patrick?
Thank you. I hope everybody can hear me okay.
Yep.
Okay, thanks. Yeah, it's good to be here. Thanks for having me. So I'm Pat Samuel. I represent a group called California Trout. We've been based in the Bay Area, right in San Francisco, for the last 50 years. This is our 50th anniversary, and I've been working at CalTrout and paying attention to Bay Area issues for about the last 5 years, and really engaging on FAHCE, which is the Fisheries and Aquatic, Fisheries and Aquatic Habitat Collaborative Effort. It's alphabet soup, trying to keep track of all these acronyms, for about the last 3 years. I'm not going to go into detail on the background of that agreement. I think my colleague at the Water District, Lisa Porcella, is going to do a brief overview of that. But what I'd like to do is just give you a sense of how we've been engaged. CalTrout was an initialing party to that settlement agreement back in 2003. And for the first 15 years or so, we had outside counsel, Water and Power Law Group, sort of engaging on our behalf in that effort. So it's almost 20 years on now, and really I've been at the table for about the last 3. Our interests in that effort are really to restore ecological health and function to those 3 creeks that it covers. So Coyote, Guadalupe, and Stevens Creeks, which Jerry just talked about. We see our role as sort of getting us to the point where we are implementing the recovery plans, the federal recovery plans for CCC steelhead, and also for Chinook salmon in the watersheds that have them. And so these are the things that are of interest to us, just sort of broadly speaking now, are really restoring stream flows, allowing functional habitat to persist. So Jerry talked about some of the factors that make the habitat functional. It's not just, is there water, but what is the quality and quantity of that water, and the right time and where it is that makes it useful for fish. And so that's some of the background about kind of how we engage in FAHCE and some of our some of our interests and other NGO groups that engage in that effort. Maybe to bring us up to present now, we have been working with the different initialing parties of that agreement on a memorandum of agreement. And so it's been, about 9 months now. We've been working on this memorandum of agreement that came on the backs of AB 3005. And so I don't know how many folks on this call were following that closely, but AB 3005 had to do with the Anderson Dam retrofit project. And so that kicked off a negotiation and discussion with all of the different FAHCE IPs, and CalTrout in a leadership role on that to explore ways we could speed up the implementation of FAHCE. Some of the objectives had been completed, some had not, and this was an opportunity to help get some momentum to move some of those things forward. Just broadly speaking now, and this, AB 3005, I should say, was eventually vetoed by Governor Newsom, but before it was vetoed, we sort of put in some work on 4 key areas, things that we'd like to see, and then just like to mention what those are in general to give you a sense of those conversations. And that language, that bill language, is publicly accessible. You can look that up, Assembly Bill 3005. The first was just getting a draft EIR for FAHCE out the door and completed as soon as possible. That's a sort of interest number 1. The second was stream flows, getting adequate stream flows at the right times, and in a pilot flows arrangement. Using adaptive management to help us understand how those changes on the landscape, both flows and non-flow measures, are impacting fish populations. As you heard from Jerry, hammered during drought. We're in another multi-year drought again, and so doing that as soon as possible is really critical before these fish blink out or just become resident populations of rainbow trout, like Jerry mentioned again. And then finally, the fourth piece is looking at a stakeholder-driven process that we're familiar with in other watersheds called river corridor management. That's basically determining what the priorities and objectives should be for a certain segment of stream that incorporates all different types of stakeholders beyond the NGO groups, but incorporating private businesses or municipalities or federal agencies and state agencies and many others to try to coordinate efforts. And the idea there is to reduce the missed opportunities to get good project work on the ground and have a shared vision for what the watershed could be. And so that's something that we're really interested in. Our continued priorities, CalTrout's continued priorities for the South Bay are the same as they are at the rest of the Bay where I work. It's really, like I said earlier, it's restoration of ecological function. So we're in these highly altered landscapes, but we still have fish. How do we mimic some of those natural processes in some of these heavily urbanized and impacted landscapes? What's the way we can try to find balance between the needs of fish and people so we can have both rather than this false choice of either or? So in the interest of time, I'm going to stop there. And if there's questions, you can put them in the chat or we could get to them in the Q&A. Thank you.
Okay, took me a minute there to unmute. Thank you, Patrick, for that update. Next up is Lisa Porcella with the Valley Water District. She is a biologist by training and currently is an environmental service unit manager at Valley Water. She oversees biology staff at Valley Water, and her current responsibilities include oversight of the FAHCE program. And speaking with her is Clayton Leal, a biologist by training and currently a senior water resource specialist, overseeing Valley Water's fishery programs. So Lisa?
Thanks, Kit. And I am going to share screen with you folks. I do have some slides to share with you today. So to save my bandwidth, I'm going to turn off my video and hopefully the slides will play okay for you. And as Kit mentioned, I will be sharing my presentation with Clayton. Clayton is also part of the group that is working on the FAHCE program. We are actively working on the biology side of the FAHCE program. So bear with me 1 second. There it is. Let's find it here. Okie dokie. So as Pat mentioned, the Fish and Aquatic Habitat Collaborative Effort is the name of the project, also known as FAHCE. And yes, it is a bit of alphabet soup. We acknowledge that. And I wanted to just give you guys a brief kind of overview of what the FAHCE program is, what our progress is to date, and where we're headed in the future. So I thought it might be a good refresher for folks, or for folks who haven't been engaged in the FAHCE program. I thought this might be a good intro. So the FAHCE program is really a solution to the water rights challenge that was brought to Santa Clara Valley Water District in 1996. And it challenged 3 of our watersheds, the Northern Santa Clara County watersheds water rights. And those 3 watersheds are the Coyote Creek, the Guadalupe River system, and the Stevens Creek system. And those 3 watersheds in total account for about 80% of our local water supply. So this was a big challenge to Valley Water. The primary concern that was brought to Valley Water was associated with the way that Valley Water manages its water supply and its reservoir releases. And the complaint claimed that this was detrimental to 2 species of fish in particular, and that's the steelhead and the Chinook salmon. So the overall goals of the FAHCE program. First and foremost, of course, the goal is really to resolve the water rights complaint. But in addition, the foundation of the program is really to balance the beneficial uses of the water that we have available. As Jerry mentioned, some of our reservoirs are very small. We really don't have enough water to do everything. And so what this program strives to do is to balance the water supply that's available. This is the local water supply that's available for both people as well as fisheries. Now, I know today we're not here to talk about the people, so I won't talk about the people. I'll focus on the fish. The overall fisheries management objectives in the FAHCE settlement agreement, and what you see here on the screen is really cut and paste out of the settlement agreement. The overall objective is to restore and maintain a healthy steelhead and salmon population as appropriate to each of the 3 creeks by providing the following: suitable spawning and rearing habitat, as well as adequate passage for adults and outmigration of juveniles. So those are the overall objectives of the FAHCE program. The other things we're striving to achieve here, of course, are to ensure regulatory compliance. So this program cannot function on its own. We need to make sure that our federal and state agency partners are along for the ride and we're maintaining in compliance with their permits. And in addition, this program is a phased implementation. There's 10 years per phase, and it's up to 4 phases that will be included in the program. And at the completion of each phase of the program, so at the completion of each 10 years, you take a look at the overall management objectives of the program. You convene your adaptive management team to oversee the program and overlook the program and see what's going right in the program and what's not going right in the program. And if that adaptive management team determines that you've met your overall management objectives, then you've met your objectives and you move into kind of the ongoing operations phase. If you haven't met your overall management objectives, then you move to the next phase in the program. And the next phase in the program may include additional restoration measures in certain creeks. It may include operational changes in certain creeks. It all depends on what the issue is and what the adaptive management team decides to target with respect to trying to resolve that issue. And again, the overall goal is to meet the overall project management objectives of the program, which is, again, to restore and maintain a healthy steelhead and salmon population by doing the following in-stream habitat improvements. Ooh, it's not advancing. 1 second. There we go. Okay, so real quick, the initialing parties. You heard Pat mention the initialing parties. In 2003, we had the settlement agreement that was initialed by 10 initialing parties. We currently have only 8 initialing parties that are still party to the agreement. In 2020, GCRCD elected to withdraw from the settlement agreement. And in addition, according to the other IPs, the Urban Creeks Council is no longer a functional organization. So they have currently been removed from the list of current initialing parties. And just to give you an idea of scale, this is the 3 watersheds that were subject to the complaint: the Coyote Watershed, the Guadalupe Watershed, and the Stevens Creek Watershed. In total, these 3 watersheds are 500 square miles of land. They encompass over 100 miles of creek and there's 7 affected reservoirs. Again, Valley Water doesn't own all of this land, but these are the affected geographical areas associated with the FAHCE agreement. So real quick, the main program implementation elements from the settlement agreement, the areas that you see here, let's see if my pointer's working, in light blue, these are what we call the flow measures. And then over here, kind of in the greenish teal color, we call these the non-flow measures. So there's 2 different components, the flow and the non-flow measures, that together are intended to work together to get to that overall management objective. There's new rule curves that are contemplated for those reservoirs that I mentioned that are associated with the 3 creeks. So this program contemplates new reservoir rule curves, which basically amounts to new discharges out of our reservoirs, specific for fish or timed for fisheries. This next one here is the timing of pulse flows to induce fish passage. As Jerry mentioned, getting fish in and out of the system is a challenge because we have small reservoirs, we have a limited amount of water supply, and then some years we just have horrible conditions like this year where we've got a horrible drought that is upon us, and it's really difficult for not only the fish, but also the people. The non-flow elements consist of priority fish barrier removal, and Jerry talked about a couple of those. We've got the Singleton barrier that we're working on with the city of San Jose currently, and we're hoping will get remediated later this year. Of course, that's pending some permits. I know there's permits in process. And then we also have some other in-stream habitat complexity elements. And those in-stream habitat complexity elements include things like large woody debris, gravel, geomorphic restoration, as well as a multitude of fishery studies that we're undertaking in these 3 creeks. Of particular note, just to mention to you guys, of the priority fish barriers that are named in the settlement agreement, there's 18 named barriers in the settlement agreement, and 10 of those barriers have already been remediated with assistance from Valley Water. The last thing you see here at the bottom of the slide is the adaptive management program, and I just wanted to highlight again that this adaptive management program is the underpinning of the whole program. It is the piece of the program which we measure the success by. It's this adaptive management team that takes a look at the annual results and takes a look at the decade intervals and says, all right, where are we achieving success? Where are we not achieving success? And what do we still need to do, if anything, to enhance things in particular creeks? So my next 3 slides, I'll try and be brief with them, but I wanted to provide you an overall history of the FAHCE program, its adaptation, and its progress. On the left side of the line here, you will see the major program activities that have occurred. And as you can see here, it starts off with the 1996 complaint that was filed by GCRCD with the State Water Resources Control Board. And then you saw kind of a big pause here. And what we have is basically the settlement agreement that was being developed and negotiated. And in 2003, we've got the initialing of the settlement agreement that again was initialed by those 10 original parties. The one thing I do want to highlight here, because I do hear this quite frequently, that Valley Water still hasn't done anything. And I'm kind of getting tired of hearing that because I wanted to show you what we have done. I know that FAHCE is not fully enacted yet, and we are striving hard to get this EIR out the door. But I did want to highlight several of the things that Valley Water has done to try and improve its operations, as well as fish passage impediments and other things that are beneficial for fisheries. So in 1998, that was the last year that Valley Water decided to make a change to its in-stream recharge program. And we basically discontinued our use of in-stream gravel dams. For those of you who don't know what an in-stream gravel dam is, it basically is a dam full of gravel that we install in the channel to increase percolation value. And we used to have these gravel dams spread throughout the Coyote and the Guadalupe system. And so in 1998, Valley Water decided to discontinue that operation, take most of its recharge off stream. We still have a couple of in-stream recharge facilities, all of which are laddered, but the remainder of the gravel dams were removed and we no longer operate in that way. In addition, in 1998, we did 2 additional fish passage remediation projects. Upper Penitencia Creek, we improved the Mayberry weir design that was there to enable better fish passage. We also worked with the city of San Jose on the not the city of San Jose, the San Jose Water Company, sorry about that, on a low flow crossing. This was on Guadalupe River. This was an old low flow crossing that they no longer needed. And so we remediated that low flow crossing by putting in some boulder weirs. In 1999, we installed some fishways, and we installed the large one that's behind our facility at our headquarters, the Alamitos Drop Structure Facility. We put in a fish ladder, and that's a over 200-foot long fish ladder. That's our longest fish ladder that we have in the county at the moment. We also installed a fishway at the Noble Avenue facility on Upper Penitencia Creek. And we also began our facility at Coyote Creek at the Percolation Pond that I believe Jerry showed some pictures of, the Metcalf facility. In 2000, we worked with the city of San Jose on the Hillsdale Avenue Bridge project. And we also did a Guadalupe Creek project where at the Masan Diversion Dam, we also installed a fish ladder. In 2001, we completed our large Guadalupe Creek restoration project that spanned from Masan all the way to Almaden Expressway as part of the Guadalupe Flood Control Project. And then in 2002, we remediated stream gauge 35 and enhanced the situation there for fish passage. In 2003, we removed the old Julian Street Bridge fish barrier, also as part of our Guadalupe Flood Control Project. And then moving along in the timeline, again, some major program activities that occurred over here. I do want to highlight for you that from 2003 to 2013, admittedly, Valley Water stumbled a bit in how to go about implementing the overall FAHCE program. And we embarked on an effort to create a habitat conservation plan and work on the federal permitting measures. In 2014, I think all the initialing parties acknowledged that that effort was not being as fruitful as we would have liked, and everybody wanted to move this project forward in a faster manner. And so in 2014, we shifted regulatory pathways and we started focusing on the state water rights and the permits. And the focus of that was so that we could change our permits so that we actually could discharge the operational flows for fisheries. So that's currently where we're at right now, is we're working on those state water rights permits and the EIR that's associated with it. In 2015, we filed those North County water rights change petitions to acknowledge to the state board that this was coming. And then on the right-hand side over here, I won't go through each and every one of them, but I wanted to show you that we didn't stop working on improving fisheries issues in Santa Clara County. We've got a multitude of things we did here in the Guadalupe system in 2004. And then in 2006, we kicked off our TMDL project, which started looking at methylation and mercury issues in the Guadalupe system. We also installed another fishway in Guadalupe Creek. We worked collaboratively with the city of Cupertino here in 2009 to do the 2,100-foot geomorphic restoration at Blackberry Farm. That project was a great collaborative project where we remediated 4 fish barriers at Blackberry Farm and provided passage over an old irrigation facility. In 2011 and through present, we continue to fund South San Francisco Bay projects for the South Bay Salt Pond Project. We've funded several scientific studies, including fishery studies, as part of that effort. And then in 2014, we've got some more improvements in Guadalupe River. And then as Jerry mentioned, that's in 2014 is when we installed the hypolimnial aeration system in the Stevens Creek Reservoir. So the Stevens Creek Reservoir hypolimnial system is actually, that reservoir is actually considered a reference point for the Guadalupe reservoirs, where we're working to remediate and reduce methylation of mercury at the bottom of our reservoirs. And Stevens Creek is actually one of our reference reservoirs. So Jerry, very interesting to hear your take on that. And we definitely would like to continue discussions with you about that operation and how it can be beneficial or not beneficial with respect to the fisheries. And my last timeline slide. We've got major program activities that have been going on here since our change in regulatory pathway. Valley Water has been really focused on getting the EIR out the door that will enable us to change those water rights. And to do that, the initialing parties, as well as the technical working group that's associated with the initialing parties, deemed that we really needed a model to take a look at the flow changes, to be able to analyze the benefits or the detriments of different flow regimes. And so we've been working really hard since 2016 on developing this new novel modeling tool. We've had over 25 meetings with the technical working group to work out the various parameters and model inputs that need to be part of that modeling effort. We've also hired a world-renowned modeling expert known as the Stockholm Environmental Institute, and they have helped us build and customize this model to include flow, temperature, as well as biological modeling. In 2019, we reached kind of a crossroads here with the Anderson Dam project. And it became very clear that the Anderson Dam project and the FAHCE project really needed to closely coordinate on their efforts. And so we are very closely coordinating with the Anderson Dam seismic retrofit project. In 2020, we kicked off our adaptive management team as part of FAHCE. And so we've already had 2 meetings of that adaptive management team to talk about the charter, to talk about where we're headed, and to talk about the ongoing pilot program that we implemented also in October of 2020, where we've implemented some of our new rule curves on both Guadalupe Creek and Stevens Creek. And then over here on the far side, I just wanted to mention, we're still continuing to work on feasibility studies. We worked on the Evelyn fish ladder remediation. We acknowledge that there's still some work to do at that site. And then in 2017, we acquired the necessary permits and began implementing our FAHCE fisheries monitoring program, which Clayton will speak about in just a minute. So real quick, next steps. Of course, there's the ongoing fisheries and flow monitoring, and Clayton's going to speak about that. We're going to continue to implement this pilot flow project in Stevens Creek and Guadalupe Creek. This affects Stevens Creek Reservoir and Guadalupe Reservoir. And this pilot flow agreement again started in October, and we plan to do it for 2 years to implement these pilot flows and see how the program works. In addition, we're continuing to collaborate with the initialing parties as well as our adaptive management team on a quarterly basis. And we're closely coordinating with the Anderson Dam project. The Anderson Dam project is going to roll in many of the FAHCE phase 1 measures into its EIR as part of the Anderson project. And the FAHCE program is going to release a separate EIR that is going to cover the Guadalupe River system as well as the Stevens Creek system. So the Coyote measures will be included with the Anderson EIR, and the Guadalupe and Stevens measures will be included in what we're calling a Two Creeks EIR that's part of the FAHCE program. And that public draft we are anticipating will be available this summer in June for public review. And I don't want to steal Clayton's thunder, but I had to end here with a quick slide of our steelhead swimming through the very leisurely swimming through the Vacky River Watcher. And that's all I've got for you. Clayton?
Perfect, thank you. Good afternoon, everyone. I'm going to share my screen as well. All right, can everybody see the presentation? All right. Right, as Lisa mentioned, I'm going to talk about a monitoring program associated with the FAHCE program. Seems to be a bit of a lag here. Is anybody seeing the presentation move forward?
Nope.
Nope.
Okay, here we are. All right, so before I start any presentation, I always kind of like to highlight my staff that's in the field doing all this work. You know, I call it the face behind FAHCE. These are the folks that you might run into while you're out in the field checking out our creeks and taking a look. Got a dedicated group. I feel at the end of the year, their arms are a little bit longer from lugging all the deep cycle batteries around to get to all of our monitoring sites. And you know, really can't speak enough to all the work that they've been doing, even during the pandemic, out in the field collecting data to make sure we can stay well aware of what's going on in this watershed. So the FAHCE monitoring program is really designed to assess habitat conditions and look at long-term trends associated with fish within the 3 creeks that are associated with this program. As Lisa mentioned, we got all of our permits, everything starting in 2017, and really started implementing a lot of the monitoring associated with this program started in 2018. That's not said that other monitoring was not conducted in previous years on the watershed, especially in the Guadalupe watershed, but this is really when the FAHCE monitoring program that was designed to look at what's going on in terms of FAHCE operations really started and expanded into multiple portions of the watershed. One of the monitorings that we're trying to implement, and we're trying to do this year, was some flow transect monitoring. This is to take a look at habitat within the creek by taking depth and velocity measurements. So this will look at what the creek is actually doing at different flow releases. So it was mentioned earlier that a pilot study was being conducted where we were hoping to be able to see how our different pulse flow events and different things that were designed for fish migration were able to be implemented. And we would go out and we'd measure these and take a look. But due to the dry water year, some of this monitoring really wasn't able to happen. We didn't reach the targets that would allow for these pulse flows, mainly because of the drought. So some of this monitoring, it did occur just to look at general habitat and base flows. So you look at these levels and you're able to look at how the flow is providing habitat, how much is available, and is it actually meeting the requirements of the fish's life history. To continue to look at available habitat, the FAHCE program has a temperature monitoring program. So throughout the Three Creeks system, there are over 47 different temperature loggers that are out collecting data. These collect data year-round, every hour on the water temperature. We've recently updated to these Bluetooth-enabled loggers that allow us to go in and download the data without actually having to take anything out of the creek or redeploy. It's been really great for folks in terms of just being able to do this quickly and download the data in a very efficient manner. You can see a map here on the right-hand side showing all the temperature locations within the Guadalupe watershed, spread throughout Guadalupe Creek, Los Gatos Creek, Guadalupe Creek, Alamitos Creek, and Claro Creek. One thing I want to remind folks, is I know a lot of you are out in the river all the time, is please don't disturb our monitoring equipments out there. We tend to notice when we start downloading data at times when the logger's been moved or pulled out, or it's amazing how many times we found them on the stream bank because somebody sees them in the channel and they pull them out and want to see what they are. But if you do find these, please try to keep them in the creek and make sure you put them back where you found them. Really would like to avoid any these anomalies we see in the data. So one of our biggest monitoring efforts is our fall juvenile rearing monitoring. So this is when we actually go out into the creek and capture fish. So we use a method called multi-pass depletion electrofishing. So electrofishing is just like it sounds. We provide an electrical current into the water that stuns the fish, that allows biologists to scoop them up so that we can get an estimate on the densities within the reach, as well as take an opportunity to do a fish condition assessment. So I say an isolated reach, we have these areas that are isolated up and downstream so fish cannot leave, so that we're able to go through and we do multiple passes using this electrofishing, and hopefully that number decreases during every pass so that we can get an idea of how many fish are present. These reaches are sampled every year, and so we can get a repeat of that habitat in each year to see trends over time. The fish condition assessment is we can take a length and a weight. We can look at how fat and happy these fish are in the system. In the Three Creek system, we currently have 33 of these monitoring stations spread throughout all of these watersheds. So while we're out doing our juvenile rearing and we have the fish in hand, it gives us an opportunity to implement a passive integrated transponder or pit tagging study. So the best way I like to think about this, it's like a fast track system like you have on the highway for your car, or it's the same as your technology that your pet has, a little microchip that gets injected. So we surgically implant these microchips into the fish that allow us that each fish has its own specific number. And this allows us to track their movement and assess the response to different flow events. Within the Guadalupe, Coyote, and Stevens Creek watershed, we have a total of 7 different pit antenna stations. So these tags aren't what are called active tags. Like I said, it's called a passive tag. So you need to have an area where you pass through that allows the tag to get excited and send the information back to a computer. Much the same as when you pass over the bridge, your little fast track system beeps and that information gets sent to you and you get a bill. For us, we're not looking for a bill. We're just looking for the timing of when fish are moving. So this has been a real interesting project. And it's been implemented in all of our watersheds, with most of our tagging occurring in the Guadalupe watershed. To date, we have 419 juvenile steelhead or rainbow trout that have received tags in our watershed. So to monitor adult migration, we're using a state-of-the-art technology called a Vacky River Watcher. This is a computer-based fish counting system that records data 24/7, 7 days a week in our systems. We have one in the Guadalupe River, one in Coyote Creek, and one in Stevens Creek. So this system uses kind of a 2 data point approach. So it records a silhouette, which you can see is that orange or yellow and red image, which is essentially a copy of the fish as it swims through these scanner plates. So when the fish swims through the scanner plate, it triggers also a video camera that turns on and records the fish, as you saw in these videos that came through. This technology allows for us to use these silhouettes to analyze fish presence in times during high turbidity, during storm events, when it's very difficult to see through the water. We can still track fish movement by looking at the silhouette, even if we cannot see the physical fish as it passed through, or make a positive identification of the fish as it went through the video camera. So all of our monitoring reports are available on our FAHCE website. I think I may have seen someone throw that into the chat, but I can also do the same thing. These monitoring reports span up to 2019 currently, and I'm hoping this week to have the 2020 reports available for folks to take a look and see all the data that's been collected in Santa Clara County over the past, since 2018. And that's all I have.
Thank you, Clayton. Yeah, this is very interesting. I do look forward to going online. If you could stop your screen share, we'll now enter our Q&A session, and we are running a bit behind. Deb Kramer will start off with some of the questions that were asked in the chat, and I will try hard to look for raised hands, but be patient with us as we try and get through these questions in a short amount of time. Deb?
Yeah, I'll go ahead and start. So Jerry, we have a few questions for you. The first one is from Stu. How important are rearing areas in the Bay marshes?
Jerry might be muted and he's on his phone. Jerry, press *6. You're on.
Can you hear me?
Yes.
At the present time, we don't know how important the marshlands are for the juvenile steelhead as they enter the bay. There are just very few indications of how important they are. It's not like coastal lagoons, which we know are very important, but for the marshlands around San Francisco Bay, it's really unknown. And one of the problems is the juvenile fish, when they hit the bay, there are lots of striped bass. And so it actually makes sense for those fish to get out of the bay as quick as possible.
Great, thank you. I have another question for Jerry. This is from Rajiv. How does reduced percolation lead to water scarcity?
I'm not exactly sure what he's referring to here. The percolation downstream of the reservoirs, you have a gradual decline in stream flow downstream because of the loss to percolation, where it's going into our groundwater system. The one water scarcity thing associated with percolation is we found out during the drought there are some contractual arrangements. So when the imported water comes in from basically from San Luis Reservoir, there's some situations if they are unable to supply, if the water district is unable to supply sufficient water for the retailers, then they give the water directly to the retailers instead of percolating into the stream and having the retailers pump it out. And that resulted in substantial reductions in stream flow in Coyote Creek. I'm not sure that answers your question.
So one more for you, and then I'll pass it over to Kit for raised hands. Jerry, are the Azure Ponds old gravel quarries? And do they cause migrating fish to get lost trying to find upstream?
There are former gravel quarries. The stream channel changed in the 90s, and the ponds are basically then captured by the stream that runs through the stream. There has been a feasibility study and consideration of taking those off channel. So you go back to an original channel and bypass those. And that would solve the problem of the warm temperatures downstream of the ponds and the predation in the ponds. The steelhead really probably don't get lost going through the ponds, but they get eaten, and that's even worse than getting lost.
Okay, thank you. Actually, I want to ask a question. I'm not quite sure who it would go to, but I know especially in Stevens Creek, I know Stevens Creek better than the others, but they do become a losing stream because of percolation, and I assume it's connected with groundwater pumping. With SGMA, the Groundwater Management Act, I know their groundwater dependent ecosystems must be protected as part of SGMA. And I'm wondering how that will monitor or restrict the pumping of groundwater in order to supply stream flows. I don't know if anyone has an answer for that.
So Kit, this is Lisa. I don't have an answer for you, but I can circle back with our groundwater unit, and Vanessa from our group can likely provide you an answer with respect to SGMA and Stevens Creek and groundwater needs.
Thank you.
The Santa Clara Valley Water District has managed their groundwater situation very well. That's what the reservoirs and even percolation of imported water is all about. So they are in compliance basically with SGMA, unlike what's happened in a lot of the water districts in the Central Valley where they're just mining the water.
Okay, thank you. I have another raised hand, Richard McMurtry.
Thank you. I have several questions. One is for both the district and for CalTrout. When will the district complete the engineering design for Azure Ponds? And when will the district initiate and complete the engineering studies for the fish migration barriers on Stevens Creek that it has concluded are top migration barriers? The second questions have to do, this is a CalTrout question, or maybe it's a district question. It's like FAHCE was negotiated in 2000 and 2003 when we had a different climate situation. Is it true that the FAHCE reservoir release curves will be insufficient during prolonged drought to enable the preservation of the fishery? Or will we need to go to stored groundwater in the winter, in the heavy years, the wet years, and withdraw in the dry years to be able to achieve the fishery goals? Starting with the question of facilities.
Okay, so Richard, I don't know that I captured everything that you asked there, but let me pick them off here one by one and you can fill in the blanks for me. So you specifically asked about Azure Ponds. So Azure Ponds, as Jerry mentioned, is gravel quarry pits. They're old gravel quarry pits. In 1997-98, when we had an El Nino event, Coyote Creek redirected itself through those gravel quarry pits. That facility is not owned by Valley Water. It is owned by county parks. And so we have been working with county parks. We produced a feasibility study. We've taken a look at whether it's feasible to pull those ponds offline. It has been deemed feasible to pull those ponds offline. However, we are not the property owner. So we are working with county parks. We are working to put together an agreement with them, an MOA, to work on a planning study. I can't give you a date as to when that facility will be pulled offline because it's not a Valley Water facility.
The county refused to sign that agreement.
We are still working with the county on the planning agreement. That is correct. They haven't refused, but we're still working with them on that planning agreement.
Well, it's been 2 years. How about the Stevens Creek facilities?
So with respect to the Stevens Creek facilities, we have 2 additional barriers that are named in the settlement agreement. We've got the Fremont Fish Ladder, as well as the Moffett Fish Ladder that are named in the settlement agreement. And those will be priorities under FAHCE to remediate those and improve fish passage at both of those facilities. I know that the Moffett facility has been studied. There's been an engineering design study that has gone on at that facility, and we're taking a look at what it's going to take to improve that facility for fish passage. We currently know that keeping it clear during storm activity helps quite a bit. So that will be probably one of the off in Stevens Creek with respect to the FAHCE program. And I don't have a timeline for you on that either. I'm not involved with the engineering design and where we're at on that, but that will be part of the phase 1 measures of FAHCE. So it should happen within the next, I can't even give you years. I don't actually know, but that's a priority barrier for Valley Water. And it is a facility that we do have some ownership over. So that is one that we are planning on working on.
Thank you.
As well as Fremont.
Thanks.
Flow,
We have
the
questions
question.
related to Stevens Creek.
Could we
So,
finish with the flow question, Deb? The question is, will FAHCE protect the streams given climate change? Or do we need to store, are we going to need to store water in wet years and the ground and pull it out in the wet weather?
So Richard, FAHCE always contemplated the full range of water year types. And so that has been built into our modeling. We've got modeling for very wet years, average years, below average years, as well as dry and very dry years. So that has been built into FAHCE. And we believe that the FAHCE rule curves will govern how the flows get discharged in the future. And it's all based on storage. So it's based on available storage in each of those reservoirs. So you're correct in that when we have a dry water year, we're not going to have a lot of water for fish. We're not going to have a lot of water for people. We're going to need to be conserving in dry water years. But the FAHCE rule curves did take into account these fluctuations in weather patterns. And so we believe, and that's why we're undertaking the pilot program right now. We believe that the FAHCE flows are intended to kind of meet the needs in the differing water years. But unfortunately, in drought years, there's just not enough water to do it all.
But there's in the groundwater. The question is, do we need to pool the groundwater just like we need to do for people? Do we need to store water for fish? That's the question.
And I don't have an answer for you on that, Richard.
Thank you. It's a good question.
I think it's time for us to close out. We still have a couple of questions, maybe quickly. For Clayton, do you have a number for the steelhead population in Stevens Creek? And also any idea about some government's resources dedicated to the importance of fish and their food, perhaps through macroinvertebrate studies?
Yeah, currently, we don't have any estimates on specific populations. Our monitoring is really just assessing trends over time, so we can look at how the densities in our juvenile rearing sites are fluctuating. In terms of additional resources, I know the SCVERP program does some invertebrate monitoring, but there's always Valley Water grants that could be applied for, and always looking for seeing anything about fish come across the table. So if there's anybody that would like to do any work, take a look at available grants and see what we can get done.
Okay, to respect everybody's time, it's 1:30 and I'd just like to close this out. First, I'd like to thank all of our presenters. So if you guys want to put in chat a big thank you for everyone, that would be super. Our next topics that we are working on are in early fall. We'll have a discussion about dams and sedimentation, and we're also working on a trails policy presentation. So thanks again, everyone, for joining us.